What if the secret to your helmet's next generation protection was hidden in a microscopic algae shell right beneath your scalp? When sunlight reaches water, tiny one-cell diatoms pull dissolved silica from their surroundings to build glass-like shells that protect them and let them use photosynthesis to make oxygen for the planet. What if we could mimic how diatoms construct their glass shells to build helmets that are both safer and more effective? That's what four researchers asked. Could mimicking how diatoms build their glass shells make helmet liners more comfortable, breathable, and reusable? Just last month, the team published their paper, D-Hat, a diatom-inspired structure for a helmet concept against trauma. Engineers have wrestled for decades to find helmet liners that deliver reliable impact protection, thermal comfort, and breathability from early polystyrene foams to modern architected materials. Yet most helmet liners still depend on single-use expanded polystyrene, EPS, or expanded polypropylene, or EPP, foams, which are lightweight plastics that crush on first impact, trap heat, degrade in moisture, and lose protection. So the researchers began by examining the frustule structure of Coscinodiscus diatoms and identifying its key architectural layers, cribrum, areolae, and foramen. They then created a Frustule-inspired CAD model by translating the diatom's geometry into a millimeter-scale TPU design, suitable for 3D printing. Finally, they tested how well the 3D printed TPU samples absorbed energy under compression and compared their performance against honeycomb benchmarks. What they discovered was pretty impressive. The optimized Frustule-inspired TPU liner absorbed approximately 10% more energy per unit volume than a honeycomb benchmark, even when printed at different scales and tested at various compression rates. It maintained its stiffness after 10 successive compressions, demonstrating TPU's hyperelastic recovery without significant degradation. In lab compression tests, the optimized design absorbed approximately 25% more energy before buckling than both the unoptimized Frustule model and conventional honeycomb foams. Now, I think this paper brings us one step closer to next generation helmet liners that combine better impact protection with comfort, breathability, and reusability. It would be great to see if this diatom-inspired TPU liner performs effectively in real-world crash scenarios and under varying environmental conditions. And now the meme of the week. Thanks for watching. If you enjoyed this deep dive into diatom-inspired helmet design, hit subscribe and check out our video on using fish scales to make an indestructible armor.